Hi everyone, my name's Lee and today we're going to be covering load testing serverless applications using an open source product called Artillery. And you're probably thinking, why are we load testing serverless applications? So we're going to cover that as well. So yeah, let's get started. So why would you load test serverless applications? Because by their very nature, they are massively scalable. So some of the things that you might want to consider are less scalable downstream services and how they react when your serverless applications horizontally scale out very quickly. You might find that you've got legacy databases or legacy services that just can't cope with the amount of load produced by it scaling out. You've got things like asynchronous, eventually consistent processes. So if you think of a customer getting an email, you'll have non-functional requirements around how long it takes for the customer to get that email. And that might be 30 seconds max, but you might find at massive scale and with batching and queues that it takes 10 minutes. So again, you're only going to see this at large peak. You've got things like hard and soft AWS regional limits. So if we think of Lambda concurrency in EU West 1, which is defaulted at 1,000, what happens at high peak when you start hitting those limits? Do you get rate limited at that point? Other things that you might want to consider are reserve concurrency. So with reserve concurrency set on particular Lambdas, you might find at scale, again, you're getting some kind of rate limiting or throttling. You also have memory configuration. So if you've got memory leaks, for example, at scale, you might find that you start hitting those upper limits of memory on particular Lambdas. And finally, just poorly written Lambdas, bad configuration, that might be with queues, for example, and you're going to see issues at high peak. So these are the reasons why you want to load test your serverless applications. This diagram shows why it's so important to load test your serverless applications. We can say at step 1 we have a database that has a finite number of database connections available. And as the Lambdas horizontally scale out, opening new connections, it soon overwhelms the database, causing it to go down. We can see at step 2 we have a legacy downstream system that can't cope with a sudden Lambda burst. We can see at step 3, async processing taking too long, which could be bad configuration on the Lambda itself pulling off the queue. We can see at step 4, reserve concurrency causing throttling at scale. And at step 5, we can see the Lambda scaling out and hitting the regional limit for concurrency. Again, an example would be EU West 1 with the limit being 1,000 as default. Artillery is an open source load, functional and smoke testing package which can be installed as a dependency of your serverless solution using npm. You can configure it using YAML files, and you can also pull in load test data with an accompanied CSV file, so you've got repeatable data for your tests. You can also run Artillery within your pipelines for regular load and smoke testing, and there are also additional community plugins to use. And if you find that you've got a particular scenario that's not covered with the plugins, then you can simply create your own and give back to the community. As part of this talk, we're going to build a basic serverless solution with 2 endpoints, allowing us to test Artillery. We can see that there's 2 endpoints, which is create employee and get employee by ID. We can see at step 1, the load test starts through Artillery. Step 2, we create the employees using a CSV file of data, asserting the responses and the latency returned from the API. We can say at step 3 that the employees are persisted to DynamoDB, which is a database. And at step 4, we get each of those employees by ID, again asserting the responses and the latency returned. Okay, so once we've pulled down the code from GitHub, go to the root folder and run npm install. This will install all of the dependencies from npm. Then if you run npm run deploy develop, this will deploy the actual solution to AWS with the stage develop. Do be warned though that running this will incur costs in your AWS account. You now need to amend the 2 config files, functional.yaml and load.yaml, replacing the placeholders with the endpoints that have just been created in the previous step. In a real-world scenario, you would be using well-defined domains using Route 53 and CloudFront, so this would typically be a one-off task. Okay, cool. So that's all deployed. We have the configuration in place. But let's go and have a look in AWS to see what's actually been deployed. First of all, we have API Gateway. So this has our two endpoints, as you can see. We've got our post, which is the create employee, and we have our get, which is get employee by ID. Secondly, we have our two lambdas. You can see that the first lambda is the create employee lambda, which is associated to the endpoints in API Gateway. You can then see the second lambda, which is the get employee by ID lambda, again associated with the correct endpoint in API Gateway. And finally, we have our DynamoDB table where our employees are stored. DynamoDB is a massively scalable AWS NoSQL database. How is artillery configured? We can see here for the load.yaml for the load and smoke tests, we're using the expect plugin within the plugins section. We ensure that the latency being returned is under 1000 milliseconds and that we have no errors returned. We can see that the payload is being pulled from a data.csv file, and we can see that the fields are ID, first name, surname and age. We can see that the order of the tests are randomized as opposed to sequence. We can see that we're skipping the header within the CSV file, i.e. the column headers. We can see that it's comma delimited within the CSV file. And we have two properties for casting and skipping empty lines within the CSV file. Next, we can see the environment section, and the first one is the smoke testing of the develop branch. We can see that we have the target API, and then we have the phases. It will run for 1 second with one virtual user at arrival and one max virtual user. Next, we can see the load testing sections. First of all, we can see the develop environment with the develop API. We see the phases. It'll run for 10 seconds with one virtual user and one max virtual user after 10 seconds. Then we can see the various other different environments. Next, we have the scenarios section. We can see that we're doing some logging. And then the first API call is creating the employees. We're hitting the /employees endpoint. We're pulling in the ID, first name, surname and age from the file. And then we expect various different assertions like the status code of 201, i.e. created, the content type of application JSON. We can see that we have a regex coming back for the response of created, and we're checking the content type as a header. Next, we have the get employee by ID on /employees/ID, and again that ID is coming from the file. We can see that we capture the full name from the response, and then we do various different assertions as before. So we're checking the status code of 200, content type of application JSON. It has the header content type, that the actual body being returned has a surname, first name, age, ID, created and full name property, and that the full name property equates to the concatenation of first name and surname. Now let's have a look at the configuration for the functional.yaml. We can see that we have the plugin section with the fuzzer and expect plugins, and we check that there's a max error rate of 0, i.e. we have no errors returned on the API. We then have the payload as before, coming from the data.csv file. And then we have the environment section, so the functional testing for the develop branch, and we can see the duration of 1 second with one virtual user. We then have the scenarios section, so we can see that we're creating an employee, and here we're missing the ID itself, and we're asserting that the correct validation message is coming back. You can see we get a 400, and the error message is invalid, data must not have fewer than 4 items, and that the missing property of ID. Next, we're checking for a bad first name, and this is where we're pulling in the naughty string from fuzzing. Again, we can see the message coming back that we're capturing is JSON, and we expect that it's a 400 error code with the data first name must match the specific pattern, i.e. the regex and the validation. And lastly, we get an employee with an ID that is not a number, so we're passing in XXX. We capture the message, we expect the status code of 400,
And now we get the message, invalid data ID must be a number.
The load test configuration gives us additional benefits over and above checking the latency and load of the system. For example, we assert that we get the correct status codes being returned, the correct content type and headers are being returned, the response body has the correct properties on it, and some additional checks around things like the full name property, which within code is a concatenation of the first name and surname properties. This gives us the confidence that our APIs are working exactly how we expect them to. Our functional and fuzz test configurations given us additional confidence in areas such as payload validation. So that's taking the actual payload itself on the API and validating that against the schema. That's checking properties against regexes, property types, over-posting, under-posting, and checking bad strings being passed through, i.e. fuzz testing. These bad strings are well documented in the industry to cause security incidents against APIs. This gives us the confidence that our APIs are secure. Okay, now we're going to run the actual load tests using the data within the CSV file. We're going to run them using npm run test load develop. And as we can see here, it's running through each of the scenarios that we have in the configuration file for the load tests. At the very end, what we'll see is a summary, and that shows the latency, response times, any failures, and any successes. We can then navigate down to the actual HTML output itself, i.e. the report. And we can also navigate down to the actual JSON object which has been generated, which actually underpins the report itself. Okay, cool. So now the report's been generated, which you can see here. If we go to the actual file, we can then open this up in a browser and view the report itself. So top left, you can see that we have the summary section, which has the test duration and the scenarios that have been created and completed. We can then see the scenario count, which we can see is 100% successful, and that we have the status codes 200 and 201. We can then see various graphs showing things like the latency, concurrent users, mean requests per second. And this then allows us to analyze how our serverless applications are running under load. You can also take the raw JSON output from running the load tests and upload them to report viewer to artillery.io. This gives us really nice PDF generated reports which you can download. The great thing about Artillery is that you can extend it using plugins, and most of these are community led. Let's have a look at some of the lists below. So we've got Artillery plugin CloudWatch. This basically takes the responses from your load tests and publishes them directly to CloudWatch. We have the Artillery plugin Fuzzer, which we've already used today. This is essentially a list of naughty strings which you can use within your tests. We have the Artillery plugin for SNS. This, very like the CloudWatch one above, will take the responses and publish them directly to an SNS topic. And finally, we've got the Artillery plugin for DynamoDB, very similar to the SNS and CloudWatch versions, but it publishes directly to a DynamoDB table. Okay, and finally, we're going to cover Serverless Artillery. Serverless Artillery is great when you need that distributed load and massive scale with your load tests. Serverless Artillery uses Lambda under the hood when you deploy it to scale out very quickly horizontally your load tests. This is a fantastic tool, but one thing to bear in mind is you should run it from a different AWS account. This means that you won't cause any issues with hitting hard and soft limits or causing any cross-contamination at all with your results. Thanks for listening, everyone.